Our DLO for today is I will solve equations with variables on both sides. And essentially what that means is that you're going to see variables on the left-hand side and you're going to see variables on the right-hand side. Sometimes you may have to distribute numbers, sometimes you're going to have to combine like terms, and we're going to work on solving for variables when they're all over the place, essentially. So make sure you have this written at the top of your paper. And here's our first example. It says to solve this problem, 3x plus 2 equals 4x minus 1. And excuse me if I'm sounding a little nasally, I'm getting sick. But essentially you guys see a 3x here and a 4x here, which obviously shows us that we have variables on both sides of the equation. Now, when we're starting to solve problems like this, I've found oftentimes that students start to get confused with when you're supposed to combine like terms and when you're supposed to do whatever you do to one side, you do to the other side. So we're going to work today on making sure that it becomes very clear when you're supposed to combine like terms versus when you should use the second rule, which is whatever you do to one side, you should do to the other as well. Now, in order to get the variables on one side of the equation, it does not matter which variable you move. So we could move our 3x over to this side of the equation, or we could also move our 4x over to the other side of the equation. It doesn't matter. It just matters what you keep track of. So if you move the 3x, 4x minus 3x is 1x, so it would stay positive. If we decide to follow the red path and we move the 4x over to the left-hand side, 3x minus 4x is a negative 1, so that would be a negative in front of the x. Now, most students like to keep it where their variables are positive. So notice here that we want to keep it so that the variable is positive. Honestly, it's up to you which way you do it. Either way will give you a correct answer as long as you are careful in keeping track of your steps. My suggestion is to, again, keep your variables positive because I think it'll help you in the long run. So if we move our variables, like the orange line says, if we move our variables over to the right-hand side, then we're going to have to move our constants over to the left-hand side. But we'll do that on the next slide. So here we go. Here's that same problem. Now, the first step that you're going to see throughout this entire PowerPoint is that it's going to say to draw the river. And essentially what they mean by the river is they have this line that comes down from the equal sign like this. And this line becomes very helpful. We're going to call it the river because it's blue. It's a straight line, so it kind of looks like a river. And essentially what we're going to do with this line is every time that you cross over that line, you have to say in your head, okay, whatever I do to one side, I have to do to the other side. Or in other words, I have to balance my equation. Because this line is going to separate our equation. It's going to create this divider so that you know every time you cross it, every time you go over it, you have to do whatever you do to one side, you do to the other. If you're acting only on one side of the line, so for example, if we're only working over here, all right, then you can combine like terms. You don't have to do the opposite sign. You don't have to subtract or add. You can just combine like terms. But as soon as you go across that river, you have to start combining. You have to do whatever you do to one side, you have to do to the other. So the first thing we're going to do is we're going to move our variables all to one side. We're trying to group all of our variables together on one side of the equation. So in order to do that, we're going to subtract 3x from both sides. So I'll subtract it from the left-hand side, and I'll subtract it from the right-hand side. Now notice over here on the left-hand side, 3x and negative 3x are called what? They're called additive inverses, okay? So 3x minus 3x is going to equal 0. And then on the right-hand side, 4x minus 3x equals 1x. 4 minus 3 is 1. So we have 1x over on this side. So when I simplify this step, I get 2 equals 1x, or just x, minus 1. And now this becomes a one-step equation, just like we had before. So we want to get x all by itself. We want to isolate x. So in order to do that, we're going to get rid of that negative 1. So we think, okay, what's the opposite of negative 1? Positive 1. So we're going to add 1 to both sides. So we'll add 1 to the left-hand side. We'll add 1 to the right-hand side. Again, these are called additive inverses. Oh, sorry, not those ones. These ones are called additive inverses. So those are going to add to 0. So on the right-hand side, oops. Here we go. On the right-hand side, we get x all by itself. On the left-hand side, we get 3. So x equals 3. Now again, notice that the reason we were doing the opposite signs here and the reason we were doing the opposite signs here is because we had to go across the river. We had to go across the river. So every time you have to do that, that's when you do the opposite sign so that you can cancel out those factors and get some additive inverses, or multiplicative inverses for that matter. All right, good. So we can check our answer, plug 3 back into the original equation right up here. So we're using this equation down here and plugging 3 into it. And when you do that, you notice that you get 3 times 3 plus 2 equals 4 times 3 minus 1. So 9 plus 2 equals 12 minus 1. Oh my gosh, I hope I don't keep doing that. Try that again. Good, and 9 plus 2 is 11, 12 minus 1 is also 11, so that works. All right, let's try a new problem. It says solve 8y minus 9 equals negative 3y plus 2. All right, good. So again, I see variables on both sides of my equations. I see an 8y here and a negative 3y here. So I want to get those on one side of the equation. I'm trying to group all of my variables together. So the first thing we're going to do, just like the first thing we're always going to do, is we're going to draw this river. So there's my river. And I want to move the variable, or the term, I should say. I want to move the term that's going to create a positive variable after I move it. So let's imagine first, let's say if I move 8y over to this side. Okay, so I'm going to subtract 8y from both sides. Well, negative 3 minus 8, that's negative 11. So that's going to make my variable negative, and I don't really want to do that. So what happens if I do the opposite? What happens if I move 3y, negative 3y, over to this side? Well, let's see, I'm going to add 3y to both sides. So if I add 3y to the left, add 3y to the right, 8y plus 3y is 11, so that's going to make it positive. So I'm going to decide to do it this way. I'm going to move the 3y over to the right-hand side. So here we go, add 3y to both sides. So over here on the right we have additive inverses, so those are going to cancel to 0, they're going to add to 0. Over here on the left we have 8y plus 3y, so when we simplify 8 plus 3 we get 8, 9, 10, 11. Perfect, so that should be 11y. So we have 11y minus 9 equals 2. We've successfully brought all of our variables to one side, so now we need to make sure that all of our constants are moved over to the other side. So I want to move 9 over to this side, because 9 is a constant, so I want to combine it with 2. So in order to get rid of that 9, again, I'm going across the river, so I have to do the opposite of adding 9. What's the opposite? I'm sorry, the opposite of subtracting 9, which would be adding 9. So I'm going to add 9 to the left-hand side, and I'm going to add 9 to the right-hand side. So here again we have some additive inverses, negative 9 and positive 9, those are additive inverses, those are going to add to 0. So always go back and check to make sure that you did those additive inverses correctly, because some students will forget to do the opposite sign, and then if I did subtracting 9 here I'd get negative 18, and I don't want that. I want to make sure I have 0 on the left hand side. So let's simplify again. On the left I get 11y. On the right I have 11, and then this is a one-step equation again. How do I isolate y all by itself? I will divide both sides by 11. Good, because right now I have 11 times y, so the opposite of multiply is divide. So I'll divide both sides by 11. Right here I have multiplicative inverses, because when those are multiplied and divided you get 1. 11 divided by 11 is 1. And it just so happens that I also have 11 divided by 11 on the other side, so that is also 1. So therefore, after I simplify, y equals 1. And I always encourage you to check your work. So when you plug 1 back into that original equation, 8 times 1 is 9. So we have 9 minus 9, so this side is 0. Negative 3 times 1 is negative 3. Oh, I'm sorry, that's not 0. Miss Martinez. Try that again. 8 times 1 is 8. 8 minus 9 is negative 1. There we go. Negative 3 times 1 is negative 3, and negative 3 plus 2 is also negative 1. So there we go. Now it checks out. My bad. 8 times 1 is not 9 at the beginning. All right, good. So it checks out. We're good to go. Our answer is good. What about one like this, where we have both of our variables on the same side of the equation already? Let's see what happens now. Again, the first thing we're going to do is from that equal sign, we're going to draw the river straight down. Now notice here that I have 7x and negative 3x on the same side of the equation. So they don't have to cross over the river. So notice that they're both on the same side of the river. Because that happens, I repeat, I do not have to do the opposite sign because I'm not crossing over the river. I only have to do the opposite whenever I cross over the equal sign. If I'm staying on the same side of the equation, I can combine like terms. So again, because I do not have to cross over the equal sign, I don't have to cross over the river, I can just combine like terms. So 7x minus 3x is exactly what you read, 7x minus 3x. So let's see. Again, notice the variables are on the same side. Yay! Combine like terms, like I just said, 7x minus 3x. Well, 7 minus 3, that's 4. Good. So 4 equals 4x. Again, all I did was I combined 7x minus 3x, combine like terms. And because they were on the same side, I did not have to do the opposite sign. So it's not like I'm going to add 3 to both sides. I often see students make this mistake. Hold on, don't write this next part down. I often see students, oh my gosh. There we go. Sorry, Miss Martinez is technologically unsavvy sometimes. Here we go. I often see students do this. They'll say, okay, I have to add 3x here, and I have to add 3x here. So this is 0, and this is 10x. So they say 10x equals 4. Again, this is a mistake, so don't write this part down. Don't do this because we're not going across the equal sign to do this step. So this is an incorrect step. Do not do that. Instead, like we were saying earlier, you simply combine like terms. So 7x minus 3x is 4x. From here, again, it's a one-step equation. So we divide by 4 on both sides. And you get x equals, what's 4 divided by 4? Well, these are multiplicative inverses. And these are also multiplicative inverses. So 4 divided by 4 is 1. Beautiful. X equals 1. Let's check our answer just to make sure we did it right. Plug it back in up above. 4 equals 7 times 1 minus 3 times 1. Correct, because 7 times 1 is 7, minus 3 times 1 is 3. So 7 minus 3 is, in fact, 4. All right, here we have one that is using the distributive property. So there are two ways to solve this. You could either distribute the negative 7 to both of these terms and then solve it like it's a two-step equation. Or, because personally I don't like to do that, I think it wastes a little bit of time. Or you could do divided by negative 7 on the left-hand side, divided by negative 7 on the right-hand side. And here we have multiplicative inverses. So negative 7 divided by negative 7 is 1. And then you're just left with x minus 3 equals positive 1. So either of those ways works. I like the second way better because I think it's a little bit simpler. I'm going to keep doing that, aren't I? There we go. So we're going to draw the river. So draw it straight down. Distribute. So again, this is showing you the first way of doing it. I like the second way, but I think more students understand it this way more. So I'll show you this way. You distribute the negative 7 to the x and to the 3. So when you distribute both of those, you get negative 7 times x is negative 7x, and negative 7 times negative 3 is positive 21. So that's utilizing the distributive property. So next we're going to solve for x. We subtract 21 from both sides. So there we have some additive inverses. Negative 7 minus 21. What's negative 7 minus 21? Think about it for a minute. Well, it's like I'm borrowing $7 and then I'm borrowing $21. All right, so I owe somebody more money. So 21 plus 7 is 28. So I owe somebody $28, which is a negative 28. So I get negative 7 equals negative 28. And then I divide both sides by the negative 7 so I can get my multiplicative inverses. And x equals, how many times does 7 go into 28? Think about it. Think about the multiplication table. 4 times. 7 goes into 28 4 times. X equals 4. Then we check our answer. Let's plug 4 back in up at the top. So we have negative 7 times 4 minus 3 equals negative 7. And that's true because 4 minus 3 is 1. So if we follow the order of operations, we get negative 7 times 1 equals negative 7. So our answer checks out, and it's correct. All right, the last thing I want to show you is these two special cases that we're going to look at. So let's look at this example here. Let's bring all of our variables over to one side. So we're going to draw the river down the equal sign. And then I want to bring all of my variables to one side. Now, remember from the beginning, we said that we wanted to bring them all over to one side so that they stayed positive. But here we have 2x and 2x. So honestly, it doesn't matter which one you bring over. So let's subtract 2x from both sides. And notice what happens. We have 2x minus 2x and 2x minus 2x. Well, those are both additive inverses, so they're both going to add to 0. So when that happens, look what we get in our equation when we simplify. On the left-hand side, we're left with 5. On the right-hand side, we're left with negative 3. But notice that that's impossible. It's impossible for 5 to equal negative 3. So when this happens, we say, because this is never true, we say that the answer is no solution. If it's impossible, if 5 will equal negative 3, no solution, because that's not true. So whenever that happens where all your variables cancel out and you're left with two different numbers on opposite sides of the equal sign, our answer will be no solutions. And then let's look at the special case. This is the last example for today. Here's the special case. So this one's a little bit more difficult, but look at it for just a minute and notice that we have some distributive properties. So I see some distributive property over here. And then we're going to have to combine all of the like terms and bring all the variables to one side. So let's do that real quick. First things first, we're going to draw the river. Then we will distribute that 3, so 3 times x and 3 times 1. So 3x plus 3, because we are distributing this 3 to both the x and to the 1. So 3x plus 3 minus 5 equals 3x minus 2. Now notice that these are like terms and they're on the same side of the equal sign. They're on the same side of the river. So we do not, again I repeat, we do not have to do the opposite sign. Instead we can combine like terms. Because they are on the same side of the river, we can combine like terms. So combine like terms, we get 3x equals negative 2. Again, if you're wondering where that negative 2 came from, it came from right here. Positive 3 minus 5. It's like saying, hey, mom and dad, I'm going to mow the lawn. Can you give me $3 for that? And then you go back to them and you say, hey, I need to borrow $5. So you got $3 for mowing the lawn. That's a positive 3. Then you borrowed $5. That's a negative 5. So now I owe them $2. So that's why it's negative 2. All right, good. And last but not least, we need to bring all our variables to one side. Notice again, I have the same thing just like I did in the last problem where I have 3x and 3x. So let's see what happens to our variables when we subtract 3x to both sides. Subtract 3x and subtract 3x. We have two additive inverses again. These are additive inverses here and additive inverses here. So those are going to add to 0. All right. So you might think it's exactly like the case we just looked at where it's no solution. But look what happens. We get negative 2 equals negative 2. Well, that is true. Negative 2 does equal negative 2. So that means you can plug in any number for x that you want, and it will always be true, no matter what you plug in for x. So what we're going to do is we're going to say that because this is always true, there are infinitely many solutions, or infinite solutions. You can also say that it's the identity. It's up to you which one you want to put for your answer, but both of those worked. So for the first special case, it was a little bit different because these two numbers down here were not equal to each other. So that was no solution. In this case, in special case number 2, it's infinitely many solutions because these two numbers are equal to each other and all of our variables were canceled out in the equation. All right, that's all we're going to do for today, so make sure you have all these notes. If you missed any of them, just go ahead and rewind the video back to where you missed, and we will see you tomorrow.